Sorry, I'm late.
All right, and the recording is started, so you guys can, Ben, you and Alex know each other, right? Or no?
Oh, I think I do.
Okay.
Alex? Yeah.
And Ben,
Ben,
from,
you look familiar. I don't know.
Yeah.
Alex West High, John from Palmer, Ben
Tech.
from Hoonah.
Yeah, Ben from Hoonah. Okay,
Hi,
so yeah, we're going to do today. It's a Alaska Coach webinar on mechanical design tips and tricks. And what I've done for today is just collected slides from presentations that I've given the last couple of years of coaching. I've been coaching FTC for quite a few years. Anyway, and you can see on this title slide down at the bottom, I've shared this presentation to anyone, and I've got two links down there. The tiny URL link works great for about a week or two before it times out, and below that is the hard-coded link. Good heavens! Use the tiny URL until the hard-coded one times out. All right. Okay, today, so much stuff to talk about, so little time to do it. So I just wanted to kind of pop through and hit some real hot spots here. John and Alex, have you coached, do you have years of FTC experience, or?
I have years of FLL, but not FTC. This is my first FTC experience. Although I have been a judge for FTC for a few years.
Oh, great. So you've seen some original designs and things like that.
Oh, yes.
Okay. So the kids, bless their heart, they always want to just jump in. They've seen the game. They want to do something creative, and they just want to start building. And we really got to put a brakes on that. I find that the first step is for me to give them instructions to build a base. And they build a base from instructions that I've given them. And in the process, what they're doing is learning best techniques, best strategy, best techniques for the whatever adopted build system. There's 4 adopted build systems out there: the ROBOTICS, the Pittsco TETRIX, the Actobotics, and the Go Builda from Modern Robotics. But have them build the base, get driving as soon as possible, and that will give them the background that they need to start doing original designs that work, as opposed to original designs that they end up sinking a whole lot of time onto because they're making a lot of mistakes, a lot of core errors here. So anyway, I listed a bunch of other topics to kind of pop through, and including 3D printing for robotics that really expands the design repertoire. Is there any specific topics you want me to dwell on or add, or anything that you see up there that, or you don't see up there?
Oh, this is pretty complete.
Okay.
We're running into problems with needing an encoder for our motors, and so if you could mention that, or just give me the 411 on what's an encoder, what's it used for. You know what?
I bundled that in with programming, so okay. I don't have any slides for that right now. So I'll answer it just front and center right now.
Okay.
The encoders basically give you motor feedback. The problem with DC motors is that their speed will change with your battery voltage. So the kids will kind of, if you think about FLL robotics, there's a big issue there too, where the kids work on some dead reckoning routines during autonomous mode, and they get it all right. And then the next day during the tournament, and their batteries maybe are somewhat drained, nothing works because, well, that 3 seconds of driving forwards, it doesn't go as far as it did yesterday. And so the solution to that for dead reckoning is to use encoders. So now you can code it. Using encoders requires a cable from the motor to the control system, the electronics. And then you code for that. And in the coding, you can actually make routines. I've had the kids build up subroutines where the encoder has actually been calibrated to millimeters. And so they can put in there, oh, I want the robot to go forwards 45 millimeters. And the robot will do exactly that with a full battery or with a half full battery. And so, and then for rotation turns that is used for dead reckoning, you can use the encoder. There's a little bit of slippage. I've also used the gyros sensor. And the only other tip for encoders is don't go at full speed. Go at half speed. Because at full speed, you're going to bundle in all these inaccuracies. Like if you give the motors full power all at once, you're going to get a little bit of slippage with the tires against the mats. Little things like that all add up big when you're doing dead reckoning. So if you go half power or 1/3 power, then that's repeatable. It'll work the same way every time. Okay, that's it on encoders. Did that? I dumped on you. Any follow-up question on that?
Just my kids are designing this robot, and they want to use one of the DC motors to lift an arm to pick up the blocks. And one of the students, my more veteran student, says, well, we need encoders so we don't strip out the gears on our motor when we lift it too high or bring it down too far. And it's just something that I don't remember learning much about in my training. So, but no, thanks. That was good feedback. It sounds like that's what we need in order for the motor to receive and use information, as far as rotating a certain amount or counting rotations. Yeah, it sounds like that's what we need.
That's exactly it. You can also put a little piece of tape on one of your gears and a light sensor, and so you can actually make an encoder that way if you're using an old motor. You can also put limit switches, so that and the limit switches will be a nice backup in case for whatever reason the encoders weren't reset correctly or you have coding issues. And the limit switch, just use regular touch sensors for that. And so when the arm is extended at a certain amount, you can just press on a limit switch to do kind of an emergency stop on that DC motor.
Right, I like it. Thank you. It's good too.
Okay, so the build systems. I have a lot of experience with the Rev Robotics, been using it for 2 years, and then the TETRIX, been using that for 7 years. I have one team with TETRIX and one team with with Rev Robotics. The ACRYLIC is very much like the TETRIX, a little bit beefier, a little bit more detailed hole pattern. Similar, the Go build I'm less familiar with, but anyway. So here's a way to get the kids started with building a robot base with Rev Robotics. On that basic bot build guide, that's actually from the resource library on FTC. I have a link on the last slide for that. And they have build manuals for robot bases. That would be part 1 of the build manual. I'd highly recommend those for getting driving as soon as possible. And they publish them in 2 editions, a TETRIX edition and a Rev Robotics edition. And then in part 2 of the manual, they do attachments that go on top of the robot base that are specific to this year's game. And it's a kind of a preliminary design. It allows you to play the game. It is not a design that you would want to go to a regional competition with, but it is a design that will get you started, especially for newbies on your team. And Rev Robotics itself has some other designs with really good build materials. And I put that on that last link, last page for links. Anyway, they have a 6-wheel drive using a drivetrain, lots of gears, a gear train, excuse me, and then another one with a chain. Chain is probably has the best success at the state championships. It's pretty flexible. You can put your motors anywhere, and it doesn't have some of the issues that with gears, you have to have those teeth meshing really well. And with gears, it's a lot more flexible that way. So you'll see some of the top teams of the state trying to do gear drives. Anyway, yeah, and Rev's got some, I'll hand out a parts index for the kids to supplement the build instructions, and a visual index of parts again. These are all available on the Rev build site. And then for the Rev, you know, reread the instructions for understanding. I have kids that build too fast and then they have to repeat and go backwards, and they build in the same orientation that the instructions are in. I see that 3rd bullet down. Let's see, other just build tips that I tell the students: assemble with loose screws. And then when all the brackets and extrusions are in place, then tighten everything. Your speed square is really helpful. The flexibility of, are either of you, by the way, using the Rev build system, or are you on the TETRIX build system?
We're TETRIX and ACRYLIC at West is what we have.
Got it. Okay.
Yeah,
So I'm just going to leave these slides up here, and I'm just going to skip over this and not talk in detail. But I will show you I've got all my new teams on Rev Robotics. I really do like the idea that they're using extrusion, which is a very popular build system now with 3D printers, for example. It's open source, tons of 3D printed parts that you can attach to your extrusion. It's got a lot of flexibility that way. And then again, building that base ASAP, and then that last step of evaluating your robot. Okay. So same thing with TETRIX. TETRIX has a YouTube channel that has a Ranger bot that's really quick and easy. It gets you building, and will teach you some ways of building. Yeah, so use their YouTube channel. Similar slide for TETRIX. TETRIX has some nut pliers to hold that lock nut that you really want to have the students use. If you hold the lock nut with your fingers as you tighten the bolt with a hex wrench, the robot will lose bolts as it drives from all those vibrations. So these are specific TETRIX tips that I've had to repeat over and over again with students. What can I say? Oh, the hubs. The hubs are really confusing. You have the axle hub and the motor shaft hub, and the diameters are different, and it's not obvious until the hubs are next door to each other. Build with your channels facing outwards, so you always have access as your robot gets more and more complex, so you can get to those nuts and bolts. Let's see. Yeah, set screws. Those things, I put Loctite on the set screws to keep them from backing out. And yeah, because loose set screws will loosen up, especially, by the way, on arms. I think it was either John or Alex, I forget which of you was saying that you wanted to build an arm. Here's a robot with an arm and an encoder. Actually, what do we use on this one? Oh, they took the motor off. Here's an arm with an encoder. I'm trying to, yeah, right there. That's on the other build system. Here's an arm that a team just built with an encoder, without the encoder cable. They're mid-build on that. Okay. Anyway, where am I? Okay. Yeah, I just put the slide up for the two build systems. My veteran teams like the TETRIX because they've learned the TETRIX, and it's got the most references and resources in terms of coaching. ACRYLIC has a bunch too. I will say that the TETRIX has been hugely upgraded from 7 years ago. All right, once the students know the build system and know best practices and they had some experience with building and having things fail and evaluating by driving and playing around. Yeah. It's time for design. And this is the engineering design process, kind of with highlights on the design part of it, step one. And again, they just want to start building, but they really need to take a step backwards and first come up with a strategy. How are they going to maximize their scoring? And then ask themselves, well, what abilities do they want their robot to have? They want to pick up blocks? Do they want to push blocks? And then what sensors, what kind of attachments do they want that will score, that will give those abilities that they seek? And finally, it's time for the brainstorming, the prototyping by play fitting the parts to visualize, the cardboard prototyping. And constraints. Teams are constrained by the season. And basic guidelines are, teams will want to spend the entire robotic season building and coding. But what ends up happening is they show up at the tournaments with great ideas, but the robot hasn't been fully troubleshooted. The reliability isn't there through practice. The drivers aren't very good at manipulating the robot, and they don't do well. And so I try to steer them into this 1/3, 1/3, 1/3. And the build, the code, and the design is iterative. In other words, they build the code, they go back to the design, they redesign, they improve, that kind of thing. And there's the full design process. Okay. And yeah, they need to write every day something in their engineering journal. And it could be sketches. Well, I say back, what do I, sorry. Labeled sketches and photos. I'm reading from the bottom of the page. Labeled sketches and photos, successes and failures, thoughts, all that kind of stuff from their journals. This is a template that I just I grabbed the original idea from an FTC team off the internet and kind of tweaked it a bit. But yeah, I have them write every day. Okay, drivetrains. This is a really good video from Aaron Kennedy. I put the link on there, and it goes through. It starts with the basic motors attached to a two-wheel drive with direct motor attachment, which is not your best performing robot. It's your entry-level robot. And then comparing that to actually the robot that's on the screen right now, chain drive, six-wheel drive, is a really versatile robot. I don't have one in front of me. I picked out 3 robots. There's another robot design that you can get on YouTube. The Mecanum wheel design. This year's competition has no mountains, nothing really to climb over. There's that center base that's, what I'm looking at it, I'm going to estimate it's maybe a 1/4 inch tall. So one of my teams is doing a Mecanum wheelbase. Mecanum wheels, oh shoot, I don't have a slide to show you. Mecanum wheels allow the robot to go in all directions. It was invented by the Navy for aircraft carriers where space is very limited. And the reason that the team picked that is because it allows the driving base to give the most amount of finesse for stacking this year's building blocks. Yeah, so don't do, try to get your teams to move beyond direct motor drive into either gears or chains. And when they go geared, I talked to them a little bit about speed versus torque. This is also a really important conversation when it comes to getting your geared arm driven correctly with a DC motor. You're going to want the biggest gear possible on your arm and a small gear on your DC motor. And that will give you your most amount of control and the least amount of skipping with your mesh teeth. Here's another slide that I've kind of grabbed from some of the different build manuals. This slide, do I have? Yeah, I'm gonna, that first bullet, mesh gears together so about 90% overlap with low friction but high contact between teeth. Yeah, if you slam the gears together, it's going to be super high friction. You want it a little bit less than that. If just the tips of the gears are touching, you're going to blow out your teeth pretty fast. Okay. Once they have the base and they've evaluated the base, these slides are taken from last year. And it's time to design and brainstorm scoring mechanisms. Typically with scoring mechanisms, you'll use servos. Servos are basically tiny motors with the encoders all built in. There's actually two kinds of servos. There's a continuous rotation servo where you only set direction. But in general, your standard servo is a set position. And some of the servos with REVRobotics and ACRYLIC will do up to about 220 degrees. The ones from TETRIX are 180-degree servos. Anyway, they're absolutely fabulous for things like grippers, things where you want to set position. I've also used them for arms when they're geared properly because the motors are small. They're really lightweight. They can't lift heavy things, although you can give them more torque through gearing, as I said. And the gears inside are, well, the ones from REVRobotics are metal gears, but they're tiny. The ones from TETRIX are nylon gears. They're very weak on any side loads. I'm really big on how to build with servos, specifically using servo mounts. And so here's a gallery of strong and wrong servo mounts. The ones on the left are good. You can see the upper left is a good one for a gripper. Again in green, you can see I've geared up a servo on an arm, and that worked fairly well for a medium weight arm. And on the right-hand side, there's a servo that's a direct connect with an arm. That servo blew out very quickly in its second game. I've asked that first picture of wrong servo mounts. That servo was just up front and center, and it ended up to be, it had a lot of exposure. It was running into other things. It was running into other robots, things like that. And with those collisions, it just knocked that gripper right off that direct servo mount, right off that servo horn. So here's an encyclopedia of TETRIX servo mounts. TETRIX has a wide range of servo mounts that have gotten really good. Their original servo mounts were not so good. REVRobotics has a more limited range, but you can use TETRIX servo mounts on REVRobotics stuff. Oh, here's an annotated picture of a servo mount that, let's see. There's 3 servos there, and one servo worked fairly okay. The other 2 did not. And then, yeah, this is my coding slide. I have my kids code in blocks, by the way. I'm not going to go into coding for this presentation. However, on the design and build mechanicals thing, I have them for the DC motors, for the servos, I have them just write specialized, just short little programs that when they design and build with a servo or build with a motor, they can just run this specific program and test that specific servo or that specific motor, away from that big, long master programs that they're going to bring to competition with them. It's just that the testing and evaluating is super important. This is a really good video off the TETRIX YouTube channel on designing robot grippers. I do tell the kids that Tim's got an unlimited amount of parts. He works for TETRIX, so it's a little unfair, but the issues he talks about are universal. I'm not going to play those videos for you then. Other things, there's another YouTube channel that's got some great ideas. That's by Aaron Kennedy. He's got 4-bar linkages. He's also the source of the robot bases slide that I showed you earlier. And the thing about 4-bar linkages, everyone wants to start building arms with a single channel. And I kind of showed you that before. These are some first builds here. You can see the single channel on the TETRIX and the single channel on the ROBOTICS. And the thing about single channels are quick and easy, but there's a lot of wobble, a lot of play. And when you're trying to pick up blocks and things like that, you're going to waste a lot of time. And so the solution to that is a 4-bar linkage. It's basically a parallelogram. And Aaron Kennedy goes into why 4-bar linkages work so well. Anyway. Okay, the thing about all of these build systems is they take time. And so, how to prototype. I've had students prototype in cardboard. I also have had them prototype visually by just making a big pile of parts and just trying to kiss fit them together. Prototyping is a tough one that I really haven't mastered as a coach. But another idea is to just have them think in terms of sub-assemblies. So have them think and build the gripper, for example, separate from the whole robot. Have them build and prototype an arm separate from the robot. And once they've tried it, troubleshooted it, evaluated it, then you can attach it to the robot base. Okay, how can 3D design and print help your robot? My teams in the last 3 years, every year we've just been using more and more 3D design and print. It could be simple solutions like holders for the phones. It could be parts that expand their design options, like there's a lot of designs on there for solenoids that basically turn the rotational motion of a servo into a linear motion. Customize gripper designs. You can print any gear ratio you want. In terms of gears, I would say printing in PLA plastic, you'll get about 2 years of use out of a gear set. And printing in ABS, I've had some of my teams are using 4-year-old gear pairs with ABS plastic. The thing that there are teams out there that are actually doing virtual prototyping and testing with 3D design, using parametric CAD programs like Creo, PTC Creo, and in Inventor, Autodesk Inventor. I haven't gone there. I've done it with some other engineering design competitions, but never with FTC, so it's a pretty heavy lift. Places to, well, if they want to come up with designs, there's designs ready to go on Thingiverse. There's the Thingiverse Customizer, which allows you to customize parts, customize designs. It runs off of AutoSCAD, which is a programmable 3D design program. And then doing mashups, and of course they can do original designs. It's not here, but I have my students use Thingiverse. It's got a really low entry design. Oh, these are some designs I've done that I've posted to Thingiverse, and then some collections on the left that I've put together for Thingiverse. Yeah. Let's see. Here's some top robot references that I've collected for ROBOTICS. And the same thing for TETRIX. And let's see. How am I doing? Time-wise, yeah, I've left 15 minutes or 20 minutes for you guys to answer any questions. Hopefully, I kind of guessed right. I kind of met your needs here. But go ahead. I'm opening it up to for questions and answers.
Yeah, thanks, Ben. You mentioned something about with TETRIX making sure that they're not just tightening the lock nuts with their fingers. You said I think you said use a nut pliers.
Yeah, here. If you hang on, I'm going to grab. I'm in the robotics build room, and I'm going to grab a set and show you. They're sold by Pittsco, and here they are. I'm bringing them to the. Here they are. Here's what they look like. I guess you could use regular pliers, but you can see with these nut pliers, they're kind of a specialized long nose, and that allows them to get into places. And not only can you can the bolt be in that orientation, but you see the end, it can also be in this orientation with those ends. Yeah, highly recommended. And I would say essential for robot bases, because those are the ones that are going to get the most the bases will get the most vibration from driving.
But using a regular wrench or maybe a screwdriver handled wrench would achieve the same thing, or is that
Yes.
tool? Okay.
Yes, you're not going to have as much clearance. I've had students use Loctite too. Loctite works. Here's the problem with Loctite, is that the bolt, if the bolt's not as tight as it should be, it will still loosen with Loctite, but it won't be apparent. And so what will happen is your robot will have, the bolt won't come off. It will stay there in a slightly loose state. And so you have a wobbly robot, and it will be less apparent, where to tighten. So Loctite, I guess you don't lose your bolts, but it's not a substitute for correct tightening.
Right. I'm also curious, Ben, how your practices are structured. It sounds to me like you have a lot of input for your student strategy, because you said, like, if you kind of go hands off, then they'll just jump straight into building, and they'll have to go back and rebuild and fix their builds, or the strategies that they'll employ just aren't the best. And you've got the experience, you've got the know, because you've seen robot after robot, competition after competition. So to what degree do you involve yourself in that design process with the kids, and to what degree do you just let them make those mistakes?
That is a great question. So I'm going to split it up into, there's the build best practices, and that I teach them and I insist on them. So for example, tightening those bolts, that kind of thing, and using motor hubs versus axle hubs and things like that. Now, in terms of the design, for starters, in Hoonah, we're a bit isolated, right? You can't drive here. So I use YouTube a lot. And fortunately, there's a lot of teams that post the design process on the internet. And some of the designs are really good, and some of them are not. Thank goodness. Because if I see them going in a certain direction design-wise, I'll pick out. Usually, I try to start the practices with kind of a cold open, kind of where I'll pick about 2 or 3 design videos that I find on YouTube that kind of address some of the design ideas that the teams are working with. And I'll start off the practice showing them the videos, and we can watch the videos, evaluate the robot, see what works, what doesn't work, and that brings in new ideas. I myself make a grade C robot where I can build it myself, because I don't put my hands on the students' robots, but I love to build, so it kind of helps me be disciplined on that matter. And I say grade C because I don't want them to copy my designs. I want them grade C as in I can scrimmage with them. But my robot is not the best solution. It just, it's something for them to try to build against or something. But back to your design question. Yeah, so I really try to stick to guidance, not answers. And they do need to experience failure. So what every week I kind of think about how they're going with their build, and try to, if I feel like they're going in a wrong direction, for example, with a build, it's time to do a scrimmage. It's time to drive and evaluate. Really push that. In other words, I don't have the students build a complete robot from start to finish and then drive it. Have them really think in terms of sub-assemblies. Build that arm, just the arm, or maybe attach it to the base if you want to, and then program just for that arm, and then evaluate just for that arm. Forget about all the other stuff going on. And let's see, instead of telling them, no, don't do that, instead of telling them, do this instead, kind of hasten them testing and evaluating a piece of their design so that it becomes apparent the limitations of the design. And then you can go back into guidance mode and say, okay, so it's not working so well here. Let's rethink about this design. Are there improvements we can make, or do we just need to ditch it and try anew? So I've had students I've had teams that really try to build the whole thing, and that's just a bad idea, because they're not doing an iterative design process that really is essential to optimizing a design. Boom.
I imagine you probably, if the mistakes that they're about to make could become expensive mistakes, like ripping off that head to that servo motor or whatever it might be, I imagine that's when you kind of step in and give a little bit firmer guidance than normal if they're about to make a mistake that's going to put an expensive part at risk. And that leads to my other question. What are some of those common things where that the kids will tend to do that are expensive mistakes, that I need to be a little bit more aware of, guiding them in a different direction? Like if I see them, like I saw in your presentation, if they're mounting a servo in a place where it's going to be a high likelihood in contact with other robots getting beat up, might encourage them to mount it in a different way. So like things like that, I'm just wondering if you have any others.
Yeah, the servos are a great example. Yeah, I put on my best practices hat, and I'll say no to that, absolutely.
Mm.
Yeah, and that's probably this. Those servos are $25 a pop. So that's probably the high. Okay, other things. Top ones, not gearing correctly and meshing and eventually stripping the teeth to gears. So the gear, starting with putting too small a gear on an arm, for example. You want to put the biggest gear, but you want to, for example, gearing arms, you really need to use gears so that the torque against those teeth is appropriate. If you put a small gear on an arm and a big gear on a motor, the torque on those teeth are just going to rip them out. So, yeah. Another one, cables. I wasn't actually prepped to talk about cables because it's more on the wiring and configuring part. However, protecting those cables. And let's see, I'm going to, I have this little hack. I ended up putting popsicle sticks on the cables. Let's see, I need to go to the room right across the hallway, and I'm going to show you my popsicle hack.
Hey, Ben.
Super glue and popsicle. Yeah, what's up?
I was going to actually ask you if this was one of yours that I found in my office. Is that what you're going to show them?
Is it a popsicle? Is it a popsicle stick glued onto?
Can you see my video? Can you see my video?
Just a minute. I can. Oh, that's it. Oh, that is one of mine.
Because I have it sitting right by my computer, so I thought this is what you're looking for.
Oh, yeah. Hey, save it for me for next year, maybe.
Yeah. Do you need it? I can mail it to you, or I can hold on to it. I've got it on my desk. But there's your hack right there.
Actually, can you mail it to me?
I can do that.
Okay. What I did for this is modern robotics electronics, and what I did is I popped the top and glued the popsicle stick inside. And then what you do is you connect the cable, and then you just put some electrical tape or any kind of tape or a zip tie, and just mount that cable down. Let me show you what I did with the cell phones too. We are, by the way, we're a pilot site for the control hub for both my teams this year, and I can't say enough good things about it. My goodness, we just set them. Are either of you doing the control hub pilots?
Yeah, we got one.
Oh yeah, we've got it. We got two.
Oh, okay. Well, then I won't take the time to go run and show you the popsicle stick on the robot controller phone, because you're not going to be using them. But yeah, securing cables everywhere. So no cables exposed to the outside. And zip ties. Oh, another thing that I used, especially for cables, I'm grabbing one right now. These little guys, they're Velcro. And you can get like a bundle of 200 for them.
Sure.
For I don't know, $3, $4, something. They're super cheap. But anyway, and you can get them on Amazon. I bought these from Monoprice. But especially in the design and build phases that are iterative, this allows you as coach to insist that all your cables are tied down, even for a moment, because these things are Velcro. And next week, when they change the cabling, they make changes to the design, these things just pop off, as opposed to zip tie, which are, I know you can get those reusable zip ties, but I like these better. Any other? Those are the three big things, actually. Servos, gear meshing, and cables, securing cables. And that's where damage comes from.
Will you ever, sorry, John, if you got a question, please just go ahead and go in, but I just go, Ben, have you ever, you said putting a big gear on an arm and a small gear on a motor, you're going to strip out that, or no, that's what you want to do, right? Small gear on a motor, big gear on the arm. Will you ever step the gears more than once? Will you do a small gear on a motor to a big gear to another small gear to a big gear to the arm? Will you, to get more control that way, or would you say that?
Absolutely. Here's an example right here.
Okay. Nice.
Yes, you can. And the mistake that people, the mistake the kids will make on something like this is they'll try to move the arm to position it. And if you, I'm going to do this just for demonstration purposes, but do you hear this?
Oh, yeah.
That? Okay, that's no good. The reason being is that this is, the mechanical advantage of this is so extreme that literally this gear cannot, this gear here doesn't have the leverage to turn the motor. You can turn the motor easily this way.
Right. And those are 3D printed gears, huh?
These, well, they could be. These gears are printed from, oh, excuse me, I bought these from ROBOTICS. These are plastic gears, but on my, I've made the, both ROBOTICS and TETRIX have posted their designs, and so you literally, you can go to ROBOTICS site, download the step file, and 3D print those gears. Here's some 3D printed gears that I've printed right there. Okay. And those are my 4-year-old ones, and you can see the teeth are still in pretty good condition.
Okay.
These are Andy Mark 8-inch wheels. This is not a good design for this year because there's nothing to climb over. Last year, this robot, look at those 8-inch wheels. This robot could go right over the crater without slowing down. Amazing climber. But this year, a robot like that has no advantage. In fact, the 8-inch wheels are not as maneuverable as smaller wheels. So, do I have any? I'm looking for 3D printed gears. I don't have any right now, but yep. Any others? Oh, here's a. Oh, here's a 3D printed. This worked for last year. This is not a very good servo mount. So if I was coach, and you can see the wobble here, I just had this is actually the design from part 2 of the build manual on the FTC resource library website. And then the bucket is my own design because they made this silly design using the ROBOTICS battery holders. Anyway, what was I going to oh yeah, so this was just a 1-week robot build, but I would say no to this because you're going to lose a servo in competition. And you can see the wobble from the single arm. So for a competitive robot, you could turn this into a 4-bar linkage, and then you could maybe put a servo over here, or maybe gear it with an axle, or just improve the bucket pickup. But this, of course, bucket is sized for last year, not this year. Here's a 3D part. Let's see. I'm going to try to grab it. Oh, this 3D part that really works well. Let's see. This is in one of my 3D part collections. Here it is. Here's the print. Some team did this, and it's on Thingiverse, and it's in one of my part collections. Look at this. The battery goes in there, and then there's the, and there we go. You have a control hub, an expansion hub, and a battery all in a single unit that mounts to your channel. Really slick.
That's pretty sweet.
The way it mounts is, I'm not sure. There's a piece that this thing slides and locks into, and that piece will mount directly to your channel.
Sweet.
Oh. This is last year, but you see the 3D printed part right here? Oh, now this one, here's an example of a robot servo mount that I allowed for last year because this is not exposed to any any contact. What it was, this was a single purpose of delivering. Oh, the little, it's not the mascot. What do they call it at FTC? I can't remember. But it's like the little mascot thingy for your team. And if you deliver it, you get points. And so that's what this is. Not the arm. It's not the gripper. It's a little delivery mechanism. And it's used for a single purpose, and it's not exposed to the outside. So, and the little item that they put on this little piece was super lightweight. So this will work. But. What programming languages are your teams using?
Mine are, they like on-bot Java. That's what they're going with, the programmers on my team anyway. I try to convince them to use blocks to kind of teach the younger kids because we're having trouble transferring knowledge down the line. To get the freshmen involved, because Java seems like a little confusing for the young kids who have no coding experience at all. So I figured blocks was a good entry level thing for them. But yeah, we're using on-bot Java.
Yeah, for me, my teams, it's their first programming experience, and there's no coding being taught right now in school, so the first and only coding experience, and so that's why I'm using blocks. But I will say that the new version of blocks has an on-bot Java window to the right, and so as you build your blocks, you can watch the Java code being built up,
and yeah,
which is super cool.
Yeah, I noticed that.
I've got the same problem. I mean, they want to do on-bot, but they really, I've encouraged them to use blocks and then use it and just go ahead and then convert over from that.
Good. Yeah, my teams, they'll go to like regionals or state, and they'll see all like the top teams in the state using Android Studio, and so. Well, they want to do that because that's the winning team. Like, you got to get there first. We're not there yet.
Okay. So you're going to post your presentation, right?
Yes. Here, I'm going to, the presentation's posted now.
Oh, okay.
And I'll just, here, I'm just going to go to right there. And I have a tinyurl.com, and you're welcome to grab it there. The only problem is tinyurl times out. So it's a Google, a shared Google slide presentation. There's my email too, by the way. So you're welcome to email me.
Then there will also be a recording of the session that will be posted on JEDC First in Alaska
Right.
website. If anybody, if
Right.
you want to direct anyone to watch this, it's available.
Good.
Can't tell you how much I appreciate you taking the time, Ben. This is really helpful.
Thanks, Alex. And thanks,
Yeah,
John.
and thanks a lot. I appreciate it.
Okay.
Awesome. Thank you, Ben. Thanks, John and Alex, for coming. Does everybody have everything they need, or shall we go ahead and be on with our evenings?
We're good. Good night. Thanks, Vicky.
I got to rush
Okay,
through the
cool.
soccer
See you guys.
All right.
Yeah.
Thank you.
Take care.
Bye.
Bye.